everyone, I'm Ying and working in the SN systems. Today I will give a lightning talk about compiling your code faster using the program repository and Ccache together. The program repository is a research project and aims to improve turnaround times. It reduces the compilation time by reusing previous compiled function and global variables. It reduces duplication by centralizing program data in a repository. The functions and global variable fragments are shared across multiple translation units. This slide shows some repo-related available materials, which include Git repository, previous talks, and a poster. To make client support the program repository, we touched the LVM optimizer and backend. We add 3 passes in the optimizer and support to output the repo ticket file in the backend. I will not explain the details here. Please refer to the previous talks. From the diagram, we can see that the repo mainly reduces the backend compilation time. Ccache is a compiling caching tool that uses textual hashing of the source files. The whole module needs to be exactly the same in order for the cache to hit. Compared to the Ccache repo reuse at function or global variable level, we could using the repo and Ccache together to build your project faster. If the file is unchanged, the corresponding ticket file in the cache can be directly used without recompile the source code. If the file is modified, the repo compiler will try to reuse the function and global variable fragment, which are stored in a database file. This table shows that the program repository reduces the backend compilation time for both changed and unchanged files, whereas Ccache reduces the whole compilation time for unchanged files. When Ccache is used to build a large project, the cache can quickly become invalid due to the frequency of header file changes. Therefore, the repo and Ccache together achieves much faster builds than using either of them individually. The LVM and Client Projector is used to show the benefits of using the repo and Ccache together. The project is built at points through its commit history. The compilation time is measured by adding time tree to all files and analyzed with Client Build Analyzer. 4 configurations are measured: ELF, repo only, Ccache only, and repo and Ccache together. This graph shows the full build time contributions. For 6 consecutive days, the first commit of each day is selected to test the compilation time. The leftmost build is with empty Ccache and program repository. Each of these commits is built in turn from left to right, keeping the Ccache content and the repo database between them. In the full build, the compiled all the changed and unchanged file for each commit. We could see the front-end compilation time can be reduced when enabling Ccache, and the back-end compilation time can get further reduction when targeting on repo. This graph shows the incremental build time contributions. Compared to the previous slide, the compiler only builds the changed files. Since Ccache cannot reduce the compilation time for the changed file, 4 configurations has a similar front-end compilation time. However, the back-end compilation time is reduced when targeting on repo. We can see, except the first commit, the repo and Ccache together gets the shortest compilation time. In summary, program repository can improve the build time when Ccache cannot. For build, up to 62% reduction compared to the ELF. For rebuild, up to 76% reduction. Now I move on to future development. We need to implement missing compiler features, such as debug information and exception handling. Also, a program repository linker is currently under development. Okay, this is the end of my talk. I hope more developers could use and contribute to the repo project. Thanks for listening.